All right, we are live for our weekly Epiphyte meetup. This is Open Air's signature open source direct air capture project that's been going on now for, in one shape or form, for a couple of years. But we're at a really interesting phase because the next iteration of Epiphyte we will be building very soon at the University of Texas, Austin. So right now, I'm joined by a couple members of the UT team, as well as Seth, who's a founding member of Epiphyte. We have a new member, Linus. I don't know if that's your actual name, but looking forward to hearing from you in a second. And then we'll have a couple other people join as well, including Will. So how's everybody doing?
Great, thank you.
Excellent, good. Linus, again, correct me if that's not your name, but let me know if you can hear this, or if you might be able to go off mute. Would be awesome to.
Yeah, I'm here. Nice to meet everybody.
Yeah, how's it going? Where are you joining us from?
Bay Area, California.
All right, so you totally intrigued me with your video that you dropped on our Discord.
Oh, good.
And I shared it here with the Epiphyte group, and I could put a couple things together just by looking at what you were showing, but it looked really exciting and potentially related to what we're doing. So I wonder if you could just quickly introduce yourself and then tell us a little bit about the project.
Yeah, hi everybody. Yeah, so I'm a machine design PE here in the state of California, and my project kind of got started in the direction it ended up because I work for a sulfuric acid manufacturing plant. So we have to deal with emissions reductions on a daily basis. And I decided to kind of copy the absorbing tower design that they have to mitigate H2S and SO2 emissions, but I wanted to change the working fluid and adapt it for carbon capture purposes. It kind of works out. The prototype I made could handle way more CO2 than you'd find in just the atmosphere. But yeah, the idea was to kind of make a lot of mistakes, learn from every mistake, and then pivot to where I actually wanted to go. Um, you, I wanted to take advantage of the waste heat from the condenser and HVAC units. That's kind of where I'm going with this to help utilize that energy for a carbon capture prototype to just kind of mitigate carbon footprint for HVAC units. But anyway, the way this machine works.
Do you mind? Is it Linus as well, or is that just your?
Oh, sorry, that's my screen name. Yeah, Scott.
Scott. Okay. Cool.
Yeah.
Scott, do you want me to just pop up like even a still of your video there? Would that be helpful?
Oh, sure. Yeah, absolutely.
Okay, cool. All right, 1 second here. All right, let me know if you can see that. So I can start it from the beginning here. Yeah, what are we looking at here?
So that's the absorbing tower. I'm not looking for longevity here, right? So like polyethylene is not going to last very long. I made sure these buckets were made out of HDPE, and I was going for cheap, right?
Yeah.
Proof of concept. Because I'm just working with myself here. I don't have much of a budget. But that bottom acrylic box, I just wanted to be able to actually see what's going on and what's happening to my fluid. It has a heating element at the very bottom and a thermocouple to regulate the temperature of the working fluid. Yeah, it's right there. Yeah. And that little black stick that's sticking into the fluid is my pH probe. That's basically how I'm going to tell if my batch is ready or saturated with CO2 or not. The working fluid is a 25% MEA solution, which is optimized for carbon capture at like between 50 and 60 degrees Celsius. So that's how I'm regulating that temperature, that thermocouple and heating element. And that fluid is then pumped up sent through a filter just to get out. You never know what could happen when you're working in your garage. PVC shavings, dirt, dust, little rocks, whatever. So I have a filter there, get rid of that before I send it over into the absorption tower, which has a 12 nozzle drip system, which you actually can't even see in the video.
Yeah.
Um, but 12 nozzle drip system that is just, yeah, it drips the MEA over 2 packed beds. These are just levels in which the fluid drips through to keep the residence time high for my solution, just to optimize adsorption. The packed beds are just plastic trays that are actually meant for like washing your car. You put them at the bottom of a bucket, and then it has a kind of a mesh to let the dirt fall through. So I use those as my platform, and ceramic. They're about 3/4 inch ceramic balls for the entire layer, allow the fluid to readily pass through. Um, you can't see those there. I have a lot of photos of these. I'll go ahead and throw up on Discord, just so you can know what I'm talking about.
Yeah, that'd be great.
And yeah, then I mean, coded everything to. I mean, it's kind of it'll shut off if once the pH reads at about 11, which will tell me it's not like a for sure bulletproof indication, but it's a pretty solid indication that your working fluid is saturated with CO2.
So when that fluid that you have, so you have the adsorbent is in the water chamber below, and then it kind of drips onto those packed beds.
Mm-hmm.
And sorry, what exactly happens then? Is that then absorbed into the material and mineralized? Or sorry, I'm just trying to. I might be considering our project too much as a frame of reference for looking at yours.
Oh yeah, no, just the MEA is just like the sponge that uh, soaks up the CO2, and like I've never the ceramic balls in the packed beds are entirely for to increase the residence time, but just make sure that fluid stays inside the chamber where the air is flowing as long as possible. Um, like I said, I think so I don't have my notebook with me where I did like um, the actual calculations, but I think this particular tower would have to run for about 15 hours for it to be completely saturated with the concentration of CO2 that's available in the atmosphere.
Hmm.
So it's very rough, and really like the main goal was to have a machine that works in a way that I understand it, and I understand what the limitations are, because I want to take the bulk data that I get from the machine working and actually try to uh, further enrich myself in the realm of machine learning. So while it is, albeit a very cheap, incredible learning experience, zero market potential, no like true functionality in the truest sense of actually changing anything. And it's old tech, right? Like absorbing tower technology has been around in the petroleum, like just oil and gas industry since I think the 50s or 60s. Um, it's making me like a more valuable person in the realm of carbon capture, just that I understand these things. And if I could further my learning with the machine learning portion of things, then even better. But yeah.
Very cool, man. And yeah, as soon as I saw it, I just wanted to make sure you were in the loop on what we're doing and we could at least swap notes. We have another open air member who used to be on these calls who I now meet with separately, who had a Epiphyte inspired DAC unit but he wanted to do a liquid sorbent type of approach. So there's a few of us that are sort of working on these little projects here that can kind of crossbreed. This one here, Scott, I'm not sure if you're that familiar with Epiphyte, what we've been doing with it, but this would be good exposure. It would obviously be cool to get your thoughts on what we're working on. But as I said at the outset, we built a version of this miniature DAC machine, which was inspired in large part by another prototype developed in Kenya with the company that's now called Octavia Carbon. They actually are making a real live DAC machine right now. They're building it in the Great Rift Valley. So they formed in open air. And so I said, all right, well, you're not using this prototype anymore. Could you let us sort of build a open source prototype around that? And so we did that. And we had some success when we built the first one at the end of last year at UPenn with some members who were, Seth has been there before. David couldn't make it today. But we learned a lot from that. And that actually sort of provoked a really considerable redesign. And now we're ordering the parts for the next build at UT Austin. I'm based here, and then multiple people on the call. So that will begin really in earnest. Some of the parts have already started to arrive. So anyway, good to have you here, have your perspective on it. Would love your ideas. So, hey, Ling.
Yeah.
Christina.
Yeah, I've been here. I've been listening.
All right, cool. Any questions for Scott before we get into some nuts and bolts of Epiphyte? All right. Okay, cool. So we had a lot of progress. Well, actually, before I do that, Thomas and Charles didn't know if, I know you guys had exams last week, so I don't know if that caused your regular Thursday meetup or Sunday meetup to not happen. But if there's any updates on your side from those, let us know.
No, we still had the meeting. We're always going to have that. Yeah, I know. Sorry we missed last week for that, but it was a stressful time. But as for the meeting, it went well. We talked more with the groups about just generally keeping going in different directions. I think everybody's still generally working on the stuff I mentioned in the Epiphyte last week, if you remember that. I can list that off again if you'd like.
Go for it.
Just programming is still working on the code base. They're working on building a state machine diagram, and we gave them a very long lecture from the other teams, so they fully understand the machine and the parts they need to program and the directions they need to go. So that's pretty good. Mass transfer, talking about a lot of different things, and investigating some of those components that you've suggested, things like that, as well as specifically investigating the specific needs of the bypass tube. Sequestration is continuing to work on wollastonite. About all that stuff, as well as like requirements for adsorption and good ways to measure that. And then chemical, they're investigating, I believe Will can speak more to that. Oh, he's not here today. Sorry, folks. He was sick this week, but they're still
He'll be on
working
shortly. He sent me a message, so he said he'll be joining.
Okay, that's good. That's good. Yeah, he was sick last week, but he's still working on that acid bath stuff for the alumina. Also, yesterday, me and Chaz met with Ling to work through the GitHub processing stuff. So we got a really good tutorial video out of that. And then also, I think we have a pretty good grasp of the basics to explain to the group. So that should be, I would say by this next meeting, we should have a pretty solid, like you can go onto our GitHub and you'll be able to tell what we're doing. Pretty solid to-do list on there. So
great.
Yeah, so we just went through the Kanban part for Christina. We just went through the Kanban part. We didn't go through like branches and stuff, but I just touched on it. If we need to figure out how to like add files and then create a pull request, then we can schedule another tutorial video thingy for it. It's just like I go through stuff and then Thomas and Chaz ask questions, then we record it and then we can distribute it to the rest of the people.
That sounds good. If anybody has any GitHub questions, feel free to message me in the Discord. And feel free to do kind of whatever on that UT branch.
Cool.
So, yeah.
Great. Evan and Scott, Evan, I was going to send you some stuff, but the best place to look at that stuff is actually on the GitHub in addition to the past videos for ours. So if you guys want to take a look at or be added to that GitHub repo, we can do that if you send along, just direct message us your handles on GitHub. I think that'll allow you to take a look at the documentation as it evolves.
Great.
Sounds good.
Fantastic. So just some updates on, this is a very active week with parts procurement. And so we had some good progress there, as well as a couple of things that we have to really reconsider, but I've already made some progress on. But in terms of what we've ordered, we have the heater, which I'll show you, that's arrived. It's right next to me, very small and cool, looks ideal. So that's already arrived. The fan is going to arrive on Friday at my house by DHL. That's the high heat fan that does have, alternate speeds that we can program it to. So we had an email thread going on with the supplier there. The sorbent was ordered, and I think it should have arrived at the lab with Will. So when he gets on, he can let us know. I ordered the monoliths this morning, made a call, went ahead. We got 150 mm by 150 mm, 100 cells per square inch. I went ahead and got 6 of those guys. Definitely 100% cordierite, not alumina or corundum or mullite, which were the other 3. So we're just going to go with, apparently cordierite is best for if there's regular cycling of temperatures. It's going up and down frequently, as ours is. That's one of the reasons why that's apparently recommended. And then Thomas and Chaz, Aaron pinged me on the Discord from the sequestration team and showed me the bag of wollastonite that she wanted. I looked at it. It's very, very fine grade, 100% wollastonite. So it looks like it checks out.
Oh, wow.
So
Okay.
I ordered that this morning. So that should arrive at my house in the next 3 days. So
Awesome.
So we got some stuff coming, and I'll quickly just show you guys this here. I did share some pictures in a video, but this is the
Arrived.
So yeah, it's really quite simple, pretty cool looking. It's about 6 inches high. You can't really see it in there, but I'm going to drop this off to you guys probably this weekend so that you guys just have it with you at UT.
Yeah, thank you.
But it looks like what we thought it would. I think we were pretty cautious there. I talked to the supplier of that a couple of times, in addition to you guys talking to them. So, and it's Omega, which is a trusted supplier. So that's cool. And then on the other, the big thing that's kind of come up is looking at the pipe that we had, the chimney pipe. The real issue we have with that is not being able to get a damper that's going to work with that. So I mentioned it last week. The damper that goes with that is fine for heat, but there's no way that it's airtight, and it just really won't sort of work for ours. So I reached out to another major supplier called Ruskin and saw like a really cool airtight, super high heat damper with our dimensions, but they cost like $1,700, right? So as I was looking at that, I picked up the old thread we had or thought process we had with possibly looking at clay pipe. If you remember back in the day, what we liked about it is it's extremely cheap. The parts for this, incredibly cheap. And it can be, exposed to, over 2000 degrees Fahrenheit. And, you can make it in various different dimensions. And there's ways of drilling holes in it where you can put all kinds of couplings into it and things like that. And when I looked at some of the other part manufacturers that do like couplings, where if we wanted to have our piece design where a bottom piece might be a foot long that has the fan, the heater, and then some space to connect the bypass tube to, these types of fittings, they have an incredibly high heat rubber seal, and you wrap it around the outside and you tighten it up. And so I called up those guys. Those are only $40, those sealers. And you can get pipes like that for like $20, $40. But the problem is when I called up, there's no local supplier. There was one in San Antonio, but they no longer sell this. That the place that is the main producer of it, one of the main ones called Logan in Illinois, I talked to their team and they could even drill the holes we wanted in the side, but they're quite heavy and they have to put it on a pallet, and you need a forklift to take it off their truck, which needless to say, do not have at my house. So that's a logistical complication. But then the other thing I started to think, and I copied Tom and Chaz on an email from this morning, which is actually one of 4 emails I sent out, is that there's a really active sculpture and ceramics community here in Austin. There's about 6 or 7 different studios. And I reached out to a few people, including one woman who used to work at UT. She used to be the like ceramics lead. And she got back to me right away, as you guys probably saw. She said, "Oh, that's such a cool project. You know, I'd love to think about it. Let's talk about it." But she's really busy, and she just sent me a lead who's at UT, who actually works in the ceramics department there. So if we were able to go ahead and make these pipes with an extruder, which hopefully they have, which is pretty standard, then, you know, it's possible we could just make these right at UT and see how that works. So I know that's a lot. The other thing I should say too is that the damper thing is really, really complicated. And one of the things I'm curious about is if for right now, we could think about automation later, but do we want to go with either a silicone plug that you could put on top and manually take off, or a clay stopper or a silicone stopper that, you know, we just for right now have to manually take off, and then later we could think about, is there a way of automating it raising or closing? But the damper thing has just been an absolute pain in the ass that's kind of slowed us down. So
I'm a fan of the manual plugs.
You think that's a good idea?
Yeah.
Yeah. So I think we just go with that.
It's like a blocker, and it's way too complicated for the frequency you need to open and close.
Exactly. That was what I was thinking. So let me know what your guys' thoughts are on the clay thing. Again, it's not just being random. It's just like, it seems like it's a good material. It's cheap. We can put the calcium carbonate and silicone into future builds. So that whole idea of storing our CO2 in the next DAC build. And then like for like $10, we could probably make those pipes ourselves, you know, rather than like $400 for steel pipes. And then if one screws up, we say, all right, let's make another one. You know what I mean? It allows us to sort of rapid prototype on it. And I think that's pretty badass. It really challenges people's sense of like, wait, they're making this out of clay. You know what I mean? That is kind of a cool look, I think, for DAC. So, but let me know if you have any questions. But again, some pretty good leads there.
I think for the plugs, like, so you as I was trying to wrap my head around it, you're just trying to put plugs where we would have put the dampeners.
Yeah.
And that could be electrified, like that could be automated still.
Let's just do it manual to start off with, but there are ways, like if we had like a plug, you know, you could put some kind of a automated, you know, lever or something that causes it to move over, you know. But I think the damper thing has been just too much of a dead end that, you know, and I think what Ling said is right, is it's a bit overkill for something that's not like constantly going on and off. You know what I mean? So let's.
Yeah, it's just like there's distinct phases that may take like tens of minutes to hours, right? And so you can just get someone to open and close. I think you will not run out of things to do if you were not working on the damper. You have plenty to do with the temperature and the sealing and stuff. Yeah, and later if you wanted to, you will have more bandwidth to work on the damper if you like sit down and have more time to research rather than trying to get it all together.
I get you.
Yeah.
Okay.
And again, we can think about a fancy way to automate it later on down the line, but you know, as Ling just said, let's not make that a blocker at the moment. And then one other thing I did want to point out, which once I got this thing in my hand, I thought was kind of interesting, is if you look at the bottom of shit, it's too big. All right, so this will work better. Okay. So if you looked at, if we were able to place some kind of a gasket or, you know, steel sort of ring in between the two pieces before we sell it, and then maybe put like a layer of neoprene or rubber so that the two pieces don't scrape, that you could actually, you know, if you take this guy here, you could screw this onto the bottom of the plate so it's turned upside down, and that would be the way that we would, you know, we can think about how do we get the heater in there, how do we attach it. But if you just put it like upside down, you know, here, and then put a plate on there, and then put that plate in between the two pieces before you sealed it, it would hang nicely. And then we'd figure out a way to put a fan on the bottom still, but that, you know, is one way to do it. And then with that steel circle, you could then put like a spacer on top of that so that there's a bit of an envelope of air, and then you just put the monoliths on top of that on the top pipe. That was kind of what I was thinking, if that makes any sense.
Yeah. The other thing is, sorry, my brain's thinking right now. It's bouncing stuff around. If you're talking about doing the plug system, and we want to do that for now, do you think it might be a better idea? Because we've been working with the programming team and talking about like how are they gonna set up that whole thing with like the temperature swing timing and the flow timing and stuff like that. Do you think it might be a better idea than just make it kind of an alert system, like notifying when we need to change out the plugs and things like that? That might be better, right?
That would be
Yeah.
awesome.
Okay.
Beep or an LED, something like that would be
Yeah.
cool. You know,
Yeah, I'll talk to them about that. That shouldn't be too big of a change. Okay.
awesome.
Hey Chris, can you pull up the heater again?
Yeah, sure. Hold it up. Yeah.
Yeah. I just want to see how big that lip is. Can you turn it?
This
Yeah,
is 4 inches.
Not
That
too
this flange.
Okay, so it's maybe like 3/4 of an inch wide on each side. Okay, I'm wondering if can you explain again what to do with the upside down? I didn't quite catch.
I was thinking, you know, it doesn't really matter because there's heat there and heat here, right?
Yeah.
And then we had to think of if we have like the bottom pipe that's a foot, we were like,
Yeah.
well, how do we get that where we want it to be? If
Uh.
you have that top plate in between the two pipes that you could drill these holes into, you could then put that on the bottom of the plate, which would still have a hole in it, so the hot air would go through. But then it's just attached to that plate, which then has, you know, this is not even supposed to be a helpful visual reference, but that to me is like an obvious thing to do it.
I think the students will also have a challenge mounting the fan, and I had suggested drilling some holes. Well, I don't know what to do now if we're gonna switch to clay, because I'm not sure if it'll be as practical to drill holes in clay. But with stainless steel walls, I was thinking drill holes, and then you can put some brackets inside the body of the cylinder, and then at least like 2, so that to prevent rotation. Then you can mount the fan on top. You don't have to use like bolts or anything inside. You can just use wires, like basically twisty ties, to mount them. As long as it's metal, it won't melt. But like maybe that bracket can also double as a bracket for the heater also.
Yeah, we could even do something where, again, if we're making our own, the other thing with the clay, it's one thing if we order an actual vitrified finished clay pipe, then you can, he did tell me about a kind of a diamond drill bit, you can do that. But if we're going to make these and then have them fired ourselves, you put the holes in before you fire it. You know what I mean? We could actually put the holes in while it's still soft and then fire it. And we could do a little piece on the bottom too that's just the fan piece or something like that, where we could put another one of those steel brackets and then fit the pipe up. You know what I mean? Yeah. So I think we can figure it out.
Yeah, if it's 2 pieces in one, then the brackets should go on it pretty easily. Even if we have to custom make it, making anything out of metal is much more straightforward than making something out of clay.
Yeah.
I mean, I really like this modular idea and these sort of hanging plates, right? So you could mount the fan to a plate as well and sandwich it between 2 pipes.
Yeah,
we can use that approach. We can have the section with our monoliths, and it's got, I don't know, some kind of, you know, very simple wire bottom, right? And it kind of solves the problem of how we swap our monoliths around. Just make it all modular.
Yeah. Absolutely. Hey, Will, it's good to have you here, man. I don't know if you caught it in the beginning, but I ordered the monoliths this morning. Unfortunately, it's going to take about up to 3 weeks to get here.
Okay.
With other stuff we can obviously work on in the meantime. Did you receive the PI from Sigma yet?
No, it hasn't gone here yet.
Okay, I didn't get any kind of notification that it was sent, but you'll at least have that. And I'm just trying to think in the meantime. I went to a Granger to see if I could just buy like a catalytic converter. We could open it up and use the monolith in that, but they didn't have it at the local one.
Oh, okay.
You know, I'd love for you to be able to get an actual monolith, not just the powder, to start making tests with, as I'm
Mhm.
sure you would too. But we might just have to wait 3 weeks for that before they come.
Yeah. Okay. That's all right. I still have some of these like little mini monoliths that I'm working on. I think we'll definitely have to do like a pre-coat or like a primer coat on these things, and
Yeah.
that's probably going to be the case for the big monoliths too. So I guess it kind of gives us some good time to be able to figure out what procedure we want to try first. Once we, how many monoliths did you order?
I ordered 6,
Oh,
which
okay.
gave us just some extras. You know what I mean? The other thing we'll want to figure out is like how many monoliths, given our fan, can we? How big do we want the pipe? You know what I mean? Like if we did like a 3-inch monolith pipe, that's like we could easily get 5 monoliths in there with still some headspace for the air circulation and for the bypass tube. But that'll at least give you one to kind of play around with. But we can, make that call.
What is the dimensions of each monolith again?
It's 6x6.
6x6. Okay.
Yeah.
And it's quarter array, or is it like the?
It's cordiorite. They had mullite, corundum.
Mm.
I did a little bit of research on. Apparently, corundum and mullite are not as good with applications where you're regularly cycling the heat.
Oh, okay.
That can damage it. So that's why they use cordiorite. Apparently, is that it's good for it gets hot, gets cool, it gets hot, gets cool, and it doesn't degrade the object at all. So it took me a while to like finally get out of them that they could demonstrate that it is actually cordiorite, not something else, but it is. So it was a little bit pricier. There was ones from $8 to $50. For these, I just went with the $50 ones, just to like that was the one that I got the most confidence that they're giving me the right product. So
Definitely.
they'll ship them in the next week, and they said by 3 weeks I'll get them and I'll just bring them over to you.
Sounds good.
Cool. Any other interesting chemistry ideas pop up on your head since last we spoke?
Yeah, I potentially might have to buy some silica, some special silica, and a polymerizer to be able to coat the monoliths. I think it's something that I can probably figure out here in my lab, though we might actually even have it. So I'm looking at procedures to be able to polymerize silica onto the monolith before we start putting PI onto it, and hopefully that'll help us. There's a certain step where you have to calcine it, so you have to just heat it up to like 600C, 500C for the silica coating, and then you can put the PI onto that, and that might actually work out better than just trying to do a straight coat right onto the surface of the monolith without anything helping it out. So yeah, figuring it out still. So I'll let you guys know. Hopefully I'll have some information or some data to show for next week.
Yeah, I would say, Will, when we have our pieces in hand for like the final one, that's when we'll bring Hirsch back on, either on this call or separately, where we can just literally, hopefully he can kind of walk us through a little bit, what his process is, in addition to what he shared already. So, but yeah, that'll be here before we know it. I know it's a few weeks off, but again, that'll be here before we know it. So.
Hey, Chris, what is the shape of the monolith? Is it rectangular prism?
Round.
Oh, okay.
Yeah.
So 6 diameter by 6 length.
Yep.
Okay.
Yeah. So it's right what we wanted. And if we had like a 7-inch interior diameter pipe, it creates a little bit of space around the side. So we should be pretty good. Cool. So those are the biggest. I'm curious if Evan is still relatively new to this, and Scott, you're brand new. Just always good to see how what we're talking about here lands or ricochets off your perspective as a newbie. Just curious if you have any thoughts, and if not, don't worry about it.
I need to become more well versed in what you guys are up to. I was trying to figure out what you guys were using dampers for. But yeah, I think I understand now.
Yeah.
Yeah, I want to get my head wrapped around everything, and then I'll feel more comfortable contributing and not wasting everyone's time getting up to speed.
Yeah. No, don't worry. Cool. All right. I think on the software side, just to go back to that, the other thing we have to think about is like the light vacuum, that if we had a hole that was drilled, if we were able to put that in the bottom of the container that we use, having that automated would be really interesting. So if we get like a beep that desorption is done, then could it automate the vacuum to pull it out into whatever chamber we use, which could be a clay chamber. That was another thing I was thinking about, is you could make tubes for the container for the gas that could be clay rather than some extremely expensive high heat plastic. But we'll let your team think that through a little bit. But
Sorry, you're suggesting that like for the when they're after it's done circulating, like the sorbent stuff, like it's desorbed fully. Like we put the plugs in, it's
Yeah.
desorbed fully. You want it to pull like into a compartment? I'm not sure I fully understand. I'm sorry.
Yeah, it has to pull into wherever we're going to do the mineralization of the wollastonite. And so I've looked at a whole bunch of different, even like vacuum chambers are kind of ideal, because apparently there's multiple things that accelerate the reaction of wollastonite with CO2 as you put it in some type of solution. If you have apply heat to it, if you shake it up a little bit, those are all things that are that accelerate the reaction time. But in any event, we have to remove it from the DAC chamber and put it into some other place where it can be contained, where that reaction can take place. Does that make sense?
Yes, I understand. I'm just wondering, like, if we already have the plug in place, is that like this is an automated system, or are you hoping like we take off the plug and then like attach something else to it?
You wouldn't need to take off the plug. You'd in fact want to keep the plug in while you're sucking the carbon out. So here would be something.
An alternative route where, like, yeah, I don't know if we're building that part, but if we're not, then it's okay to go baby steps and not build it in yet.
Yeah.
Because you're juggling like 7 things on your first prototype, and it will be really hard to isolate factors that are causing problems.
Got it. Okay.
Yeah. What I recommended to Aaron was, if they just independent of the DAC machine, they're getting the wollastonite soon, is that there's to start to think about what are those things that are known to accelerate the reaction, and can they start doing some experiments, to sort of first just expose CO2. We can get like a soda stream or whatever we want to do, and start just playing around with mineralizing wollastonite with exposure to CO2. You could even use that existing CO2 sensor that you have and see how the wollastonite reacts at 5,000 ppm, 10,000 ppm. Like there's a lot I think that they can do before we even think about how it would integrate with a DAC. All right. Any other kind of thoughts or ideas on your guys' side?
I'll have to think a little bit how much the plug is going to impact all the other stuff. But I think the biggest thing that's a good thing about the plug is it's going to guarantee a seal. That's not too complicated with the plug. So it's going to guarantee a really good vacuum, which I think is going to do us a lot of good.
Yeah.
I'll have to think about. I got to sit on it for a little bit, but for sure we'll talk about it in our meeting. I'll release in different teams, see what they think about it, and we'll definitely get back to you next week.
Cool. Are you guys going to be meeting up this Sunday as normal?
Probably me and Chaz will not. We're going on a trip to Wurstfest. I don't know if you know what that is down here in Texas.
Bratwurst, like the German Texans, is it that? Yeah, okay.
It's a German festival up in New Braunfels or Green, one of those two places. A friend of ours lives there, and he's hosting like a bunch of us up there. So we will not be, but we will have some sub-team heads that will be running the Sunday study. So
Okay.
it'll be happening. Chaz and I just won't be there.
All right. What I might do is even see if I can hook up with you guys on Friday just to drop off the heater, and then the fan is arriving in the morning, according to DHL. So it would be cool to just kind of get those to you, just hand them off to someone so you guys can have them in hand before the following weekend.
For sure. Also, those sub-team heads are also, you can drop, if you want to still do Sunday, you can definitely drop off stuff to them too. They're somewhat trustworthy. So.
Okay. All right. I'll try to make that. Maybe bring my son along with me. All right. That sounds good. And then with the clay pipe thing, I am going to email this woman, Emily Lee, who's at UT at the ceramics department, right after this call with you guys copied on it. And if we can get her interested in the project, that could be extremely helpful, to have her be able to just sort of crank out some pipes for us. But we'll have to ask. So, So anyway, all coming together. But let me know if anybody has anything else to sort of share or talk through. But we're reaching a interesting stage. All right, looks like we're good. Seth, how about from you? Just having the last couple weeks, I mean, would be cool to get a sort of a jump on the sensor testing now. I brought the sensor over to those guys, and they have another one too. So I don't know if there's any kind of things we want to start doing with just sort of testing those out outside of the DAC unit, like putting them inside of a cup or something and spraying some CO2 into it, or I don't know if you have any thoughts on that we could possibly direct the software team towards.
Yeah, I mean, if you guys haven't worked with these kinds of sensors before, then absolutely it's worth just spend some time, hook them up to a simple board, just start getting some data, understanding what the readings mean, and try out some different things. We can certainly, if you are more familiar with them, then yeah, it'd be great to start getting some sense of what their calibration looks like and so forth, like Chris mentioned.
Yeah. All right, cool.
I mean, the first thing you want to do is make sure you know how to make them work.
How to what?
How to hook them up and make them work.
Yeah.
Start there.
Cool. Thomas, do you think some of the software people like Caleb would be there on Sunday?
Oh, for sure. Yeah.
Okay. Cool.
I can. I'll follow up with you on like the plan for the weekend. On the Thursday meeting, I'll talk to the sub team heads and get one of them to host that and see who's going, and I'll keep you updated on that.
Okay, sounds great. So I will go. No soccer game on Sunday for me, so I can pop by.
All right, sounds good.
All right, guys. Well, that's all they had. Exciting. Ling, anything else?
Yeah, so I'll be officially leaving the country on November 20th. And then after that, internet will be very questionable. I'm not sure what the situation will look like, but I might be on a unlimited data plan, and then I could check my messages and stuff, but the calls could be at a weird time, I think. It might be like 1 a.m. So I think before then, something that I could help with is if the mechanical sub team, I think maybe they're called mass transfer, if they want help mounting the fan or the heater, if they want opinions or suggestions on how to do it, I could help brainstorm. So like if I don't know, like let them know that I'm available as a resource until November 20th, and then we can talk about specific parts and what needs to happen to get things mounted and like stable.
That's one of the things they're looking into right now. So I'll definitely tell them to message you if they have any.
Yeah, if they have opinions, by all means. But if they need a brain to pick, I'm here.
Sounds great. Thank you very much.
Great. All right, guys. Thanks again, Scott. Thanks for joining. Hopefully this was more illuminating than confusing, but really excited about your project. So definitely hope you can stay in the loop with us. Yeah, so we'll see you guys on the Discord, and we'll see you next week. And I'll see some of the UT people in person on Sunday. All right. Bye.
Thanks, everybody.
All right. Thank you, Chris.
Thank you.